This is the last thing that we are going over in the quadratics unit. This is it. We're done. Whew. All right, that means that tomorrow we are reviewing. Tomorrow's Thursday. Tomorrow we are reviewing. Friday we are testing. All right. So a system of equations. Does anyone remember from Math 1 what a system of equations is?
No. I remember the words. Yeah, I have no idea.
Okay. It is two or more normally we would have lines, but here we're going to have parabolas. So we're going to say lines or curves. So I'm going to put slash lines or curves. That cross. And the single point where they cross, or in this case, because we're talking about not just straight lines crossing, straight lines cross at a single point. But if you have a U-shaped graph and a straight line, then they could cross at a single point, right? If you had this straight line crossing and touching the vertex, it would be a single point. They could cross at 2 points if you have the straight line cutting into the U shape, or they could not cross at all if the straight line went underneath the U. So this is two or more lines that cross, and I'm going to put or don't, because maybe they don't, at 0, 1, or 2 in this situation, because here we're talking about a straight line and a U-shaped graph, okay? 0, 1, or 2. For different types of equations, it could be different things, okay? So two or more lines or curves that cross 0, 1, or 2, depending on the situation, it could be infinitely many points. And we label those points as x, comma, y, okay? So two or more lines or curves that cross, or they don't cross at 0, 1, or 2 points. That's what we're going to do for this particular graph. Okay. Normally, a system of equations would be lines that cross at a single point. They would only not cross if the two lines were parallel. They would cross at infinitely many points if the two lines were exactly the same line, then they'd be crossing the whole time. So that's what you guys learned in Math 1. Now that we're talking about Math 2, we're doing a straight line and a U shape, but we know that we could do like, they call them polynomials, where they're like super curvy, right? And then a straight line could cross that like 7 times. You know, it kind of depends on what you're talking about. So here we're specifically talking about a U-shaped graph and a straight line. So let's go ahead and graph the straight line first. So here we have y equals 4x plus 1. So we have to go back into our Math 1 brains and think about how we graph this. Does anyone remember how to graph that from our Math 1 brains? Yes, Peter. Okay. Okay, so 4 is the slope, 1 is the y-intercept. So this is in y equals mx plus b form. So if you guys recall, we would always start at the y-intercept of 1, and then the slope was rise over run. We were always most comfortable if that slope was a fraction. So if I take the whole number 4 and write it as a fraction, that would be 4 over 1. So it would be rise 4, run 1, rise 4, run 1, rise 4, run 1. So from there, I'm going to go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. Ms. Rice, do I have to do it for the whole graph? Yes, I made the graph this big on purpose. Okay, we need it to be this big. Now, I ran out of room going to the right, so I'm going to do the same pattern, but to the left, and I'm going to kind of do the opposite of the pattern. So since I was going up 4 to the right 1, I'm going to go down 4 to the left 1 in the opposite direction. Okay? Say it again. like sketch it out. Whenever we do systems of equations, we want to draw the points because we have to draw a more accurate line than normal. So if you are solving a system graphically, your points need to be more accurate than they normally are because we're trying to see where these lines cross, and we don't want an inaccurate answer, we want an accurate answer. So normally if you're just sketching a line, then doing a couple points and sketching it out is fine. But if you're solving graphically, your points need to be accurate. Uh-huh. And okay. Oh, I got you. So you're not putting dots, but you're still being accurate about it. That's fine. Yeah, that's not a big deal. Okay, so I'm going to go ahead and I'm just going to take another sheet of paper and use it as a ruler. Ms. Rice, why are you doing that? Why are you being stingy about rulers? Because I don't feel like handing them out, okay? Okay, there's a pretty straight line. I don't know. It's okay. All right. Now, this quadratic is written, it's written in the standard form, x squared plus 1. So x squared plus 1. So what information can I get about that parabola? Y equals x squared plus 1. I want to be able to graph that. Okay, so my y-intercept is what? 0, 1. Okay, so there's a point. There's a point where they cross already. Okay. What's some other information I can get from the standard form? I can get the axis of symmetry. AOS, axis of symmetry. And how do I get the axis of symmetry? X equals we do negative b over 2a, right? And there's no b value, right? Because the b value is the number in front of x. This would be like x squared plus 0x plus 1. And so if we do negative b over 2a, that'd be negative 0 over 2 times 1. And negative 0 over 2 times 1 is just 0. Okay. So for my axis of symmetry, that's just 0. So that means that my y-intercept is actually my vertex. So this is not only standard form, it's also vertex form. Okay, so that's kind of annoying because we were hoping to get some more points and we did not. So here's my axis of symmetry. Okay, so at this point, I'm going to get my calculator out, and I'm going to have my calculator. So we only have the point x equals 0, so let's use the calculator to plug in some more numbers. So what other number could I plug in if I only have 0? Should I plug in something so far away from 0? Probably not 4. What should I plug in? Probably 1. Okay, 1 is probably a good one. So I'm just going to plug in some numbers. So I'm going to use x equals 1. So plug in 1 for x. And then I've got x squared plus 1. I get 2. So 1 gives me 2. And then I've got my symmetry there. So I'm going to keep this kind of organized because these are my notes. So I want to make sure that this makes sense. So I'm going to say on here, I'm going to say other points. So I have 1, 2. Okay, and then I reflected it. Okay, so I've got negative 1, 2, 0, 1, and 1, 2. What's another point I could plug in? Okay, how about we plug in 2? Let's plug in 2. Okay, so I'm plugging 2 in for x. Let's go up here. 5. Okay, so 2 gives me 5. And I'll reflect that over. I'm going to go ahead and do these in marker just so that you guys can see what is different from the straight line. So here's my parabola points. There you go. So we can tell you cannot even tell that those are orange. You'll be able to tell the next ones when I start doing them stop doing them in pencil. Okay. Okay. Now we'll take Jack's advice. We'll do 3 next. Okay, so 2 gave us 5. 3 gives us 10. Do you guys see that we're getting closer to crossing the line again? Okay. So I'm going to go ahead and plug in 4 next. Ooh, look at that. Okay. Okay, so the solutions are where they cross. So one solution is right up here. And then one solution is right down here. And so the solutions are 0, 1, and 4, 17. So if you plug 0 into the first equation, you get 17, or you get 1 as an output. If you plug 0 into the second equation, you get 1 as an output. If you plug 4 into the first equation, you get 17 as an output. If you plug 4 into the second equation, you get 17 as an output. So those are the 2 solutions. Okay. How are you guys feeling about solving graphically? Can you do it? Okay. I chose the grossest one to do as notes. So the ones that I gave you guys to do as practice on the sheet that I haven't handed out yet, those ones are smaller graphs. I think they'll be a little bit easier to do. Okay. Algebraically. So algebraically means we do it completely by hand. We do not graph anything. All right. So for this one, when you have problems like this, where both of the y's are already isolated, you say, okay, if y equals this and y equals this, then these 2 things must equal each other. Okay? So we're going to say x squared minus 4 should equal 6x minus 13. And then from there, you have some wonderful flashbacks. And you go, oh my gosh, that's a quadratic equation. I have 4 options. I can factor. I can use the quadratic formula. I can complete the square. I can solve by taking square roots. I have so many options. So many options. Okay, so when I look at this, I think, okay, typically when I work with a quadratic, I want it to equal 0 before I figure out what method I can use. So let's go ahead and make it equal 0. Do we want to leave the x squared term on this side, or should we move it to the other side? We want to leave it there. And the reason we want to leave it there is because currently that x squared term is positive, which is what we like. Okay, so I'm going to subtract the 6x over, subtract it over, and add the 13 over, make that equal 0. Okay, so I've got x squared, and then what else do I have? Minus 6x plus 9, okay. So if you look at this problem, because there's the 6x there, I can tell that this is not a good taking square roots problem because we cannot do that with an x term. So taking square roots is out. But if I look at this problem, I can tell it's a good candidate for quadratic formula. It's a good candidate for completing the square because it's an even number, so it's easy to kind of divide in half. Is it a good candidate for factoring? Yeah. So I probably want to do factoring if I can. That seems to be easier than the other two methods. If I can factor, I'm going to factor. All right, so I'm looking for two numbers that multiply to positive 9 but add to negative 6. And what are they? Negative 3, negative 3. So x minus 3 equals 0. And what is my only one solution, actually? X equals positive 3. All right. So what that means, if we only have one solution, and we are not done, by the way, because we only found the x-coordinate, we need to find the y-coordinate. But if we only have one solution, what does that mean about the picture? We have a U-shaped graph and a straight line. Where is that straight line hitting the U-shaped graph? At the vertex. That's what that means. It's got to be hitting it at the vertex, right? Okay. All right, x equals 3. Let's go ahead and plug it in. Which one should we plug it into? The first one? Okay. It doesn't matter, right? When you're solving a system, it doesn't matter. Okay. So we'll plug it into the first one because that's what Asa said. So Asa said, first one, so we got 3 squared minus 4. 3 squared minus 4 is 9 minus 4, which is 5. Now, we don't box our two answers because the place where these cross is a single point. So we always want a single point to be written as an x-coordinate and a y-coordinate. So I'm going to write this as 3, 5. All right, let's do the next problem. Okay, so this one, if you guys can see this one, the y's are not alone in both equations. Okay, make them alone, isolate them. Okay, so now we can isolate the y's in both equations. That is certainly an option. Or what we could do is isolate the y in only one of the equations and then just plug it into the other one. Would you guys rather do that? That's okay with you guys? Okay. So typically the y that we isolate is going to be in the linear. It actually doesn't really matter. You can isolate whichever y is easier to isolate. So which y would you guys like to get alone? Do you want to get this y alone? Or do you want to get this y alone? The bottom y? Okay. So we got 5x minus y equals 15. How are we going to get that y alone? Say that again. Subtract the 15, and then add the y. Okay, so 5x minus 15 equals y. Okay, so we have rewritten the bottom equation so that the y is alone. We are comfortable with that. We are good. Okay, now you guys have concluded we do not need to get the y alone in the top equation. We are good without doing that. Okay, so what do we need to do with that top equation? I'm going to circle the y right here. That y and this y are the same. So we're going to take this y out. And what are we going to replace it with? Okay, so I'm going to write x squared equals 2. I'm going to replace the y. And I'm going to write plus 6. So x squared equals 2. I'm going to replace the y plus 6. And then what am I replacing y with? 5x minus 15. Okay. And what should I be doing now? So I did substitution. That's what I was doing. And how do I get rid of the parentheses? Distribute. Okay, so x squared equals. Okay. Okay. That's minus 24. So what do you guys think we should do next? We have a quadratic equation that we're going to be solving. We need to make it equal 0. So are we just going to subtract the x squared over to do that? No, why not? It makes it more difficult to have a negative x squared term. So we don't want to make it more difficult on ourselves. So what should we do? Subtract the 10x, add the 24. So that makes it more difficult in the meantime, but it'll make the rest of it easier in a moment. Okay, so that side is 0 now. And then what order do I write this stuff? Okay, so there's a 10x there, which means that taking square roots is not an option. So our three options are factoring, quadratic formula, and completing the square. Factoring is a good one. So we're going to look for two numbers that multiply to 24, but add to negative 10. So, okay, so why didn't negative 12 and 2 work? Do you know? They add to the right thing. They multiply to a negative. So that's why they don't work. Okay, so what are we going to use instead? So negative 6, negative 4. So, okay, so we got x minus 6, x minus 4, okay. And so what are our two solutions? Okay, so we are not done though. We can't just put a box around those and call it good. What do we have to do? Find the y's. Okay, so I'm going to write it when x equals 6. So where do you guys want to plug it into? Yeah, I would do it right here. So you have this equation, you have this equation, and you have this equation. Now this equation is going to be the easiest one because you have the y alone. So if you take the x and just plug it in, then the y is already by itself. It's already solved for. So 5 times 6 is what? 30. 30 minus 15 is 15. So when we have x is 6, y is 15. Okay? 5 times 4 is 20. 20 minus 15, 5. So y is 5. Okay? So our 2 points are 6, 15 and 4, 5. Okay. Now, I have to admit something to you guys that makes me very sad to admit. I was wrong on something. No, I was just wrong on something. You can cross a parabola at one point without it being the vertex. It's been bothering me this whole time because I knew that 3, 5 was not the vertex, and I was like, how would you do that? So we're going to graph this one on Desmos real quick so you guys can see how you can cross a parabola at one point and have it not be the vertex, because if you have x squared minus 4, that vertex is at 0, negative 4, and this is not 0, negative 4. Okay, so we're gonna look at that one. I figured it out in my head. You have a slanty line, so it's hitting the side at one